It's Thursday, 22nd of May, 2025, and welcome to today's Water Action Platform on water and space, where we explore our planet's most precious resource in the context of humanity's greatest frontier. Today, we'll hear about the Aqualunar Challenge, an exciting space-based competition, and meet the winners. We'll delve into new water technologies in space and some that have found their place here on Earth, and finally listen to the first music on Mars. But before that, I'll remind you that the Water Action Platform, Executive Exchange, and the Trial Reservoir are only possible thanks to their sponsors, these wonderful organizations shown here. The Water Action Platform and its sister podcast, the Executive Exchange, are free to all because of these companies. The Executive Exchange is available through platforms like Spotify, and here you can listen to water utility executives telling peers stories about special projects or particular challenges they faced. Here is the link to hear their short stories on unusual and interesting topics. Water and space. Since 1976, the NASA Technology Transfer Program has connected NASA resources to private industry, referring to the commercial products as spin-offs. Well-known NASA spin-offs include memory foam, freeze-dried food, firefighting equipment, emergency space blankets, dust busters, cochlear implants, infrared thermometers, and camera image sensors. But what about water? The relationship between water and space exploration is both fascinating and essential. In space, water is literally worth its weight in gold. It's crucial for astronaut hydration, oxygen generation, radiation shielding, and even as rocket propellant when it's split into hydrogen and oxygen. The International Space Station recycles approximately 93% of all water on board, from humidity in the air to urine, because launching water from Earth costs thousands of dollars. This need for water conservation and purification in space drives innovations that benefit us here on Earth. The Aqualunar Challenge is a $1.6 million international challenge prize focused on making human habitation in space possible by finding ways to utilize water found on the Moon. The Moon contains significant amounts of water ice, particularly in permanently shadowed craters at its poles. Around its south pole, an estimated 5.6% of the soil, or regolith, is water frozen as ice. The Aqualunar Challenge set innovators the task of developing technologies to harvest and purify this water ice found in the lunar soil. Isle Utilities' Caroline Wadsworth worked on the Aqualunar Challenge to bring together scientists, engineers, and innovators to create systems to efficiently extract and treat lunar water. 10 cutting-edge teams were named as the finalists in June 2024 and awarded £30,000 each to develop their technologies further. Let's hear from Caroline and some of the finalists now.
Caroline, thank you so much for coming on Water Action Platform.
It's a pleasure.
What was the purpose of Aqualunar? Give us in a nutshell what Aqualunar is all about.
Super. So the Aqualunar Challenge is a £1.2 million challenge prize fund, and the aim was to find a series of solutions that would be able to purify 1 litre of water an hour on the Moon. There are pockets of water on the Moon. They're all on the dark side of the Moon, so you can already see that there are some challenges coming into how these solutions might work. But there are ice pockets that have obviously contain water, but also a number of different contaminants, and regolith, which is really the sandy kind of surface of the Moon, and it's very coarse and causes lots of problems in that purification process. And the aim was to create, if you could create 1 litre an hour, in theory, that's just about sufficient to be able to allow humans to live for longer in space. So that could either be on the surface of the Moon, and that would allow them to have vegetables and grow different kind of crops that would allow them to eat and live there, but also as a source of water for them to drink. and as a source of fuel to allow them to go further into space.
Oh.
And actually, water is one of the heaviest elements or items that they take up to space. And a lot of the cost of exploring space is dictated by the weight of the space rocket that goes up. So the more you can reduce that weight, the cheaper that space exploration becomes. And obviously, the longer they can stay there. So the greater the reality or the chances of getting to Mars become if we can have a source of water actually out there in space.
Much better chances. So it's water for human consumption, for food production, and for fuel. I didn't realise that bit. Okay, that's really interesting.
Yeah.
Now that we're at the end of the Aqualunar Challenge, or almost at the end of it, what are the main outcomes that you've seen emerge from the challenge taking place?
We have selected 3 winners. So there's a winner, a first runner-up and a second runner-up. But actually all of the entrants were amazing. So I think the main outcome has been an accelerated journey for those participants through that challenge. They not only got to mix with each other and bounce off each other, they got access to a range of experts, whether from within ISLE, from a water perspective, or our partner organisation, Exotopic, who provided more space-based expertise. So they've now accelerated through their journey of coming in at a really very, very early stage, so very immature solutions, through to still relatively immature solutions, but they've moved on in leaps and bounds, and they've had access to test facilities, for example, that they would never ordinarily have had.
When it comes to sort of implications or applications in the real world, what's the value of the outcomes that they've had, those introductions to the space community and the water industry?
Well, huge value to that. So the transferability from space to the terrestrial applications, it is massive. And actually, when you look at the reality of the space market versus the terrestrial markets, the terrestrial markets are a much nearer term opportunity. So if they want to stay afloat and be around for long enough to actually take advantage of those space markets, they need to really grab hold of these terrestrial-based market opportunities. So we've been able to introduce them directly to water companies that could potentially be deploying these, but also a range of other and potential end users, because the applications are so broad of this kind of solution that they're developing. And we've also been able to advise them of the type of solutions that they're competing against, so they understand what they need to displace or what their USP is against those. Just huge opportunities for them moving forwards. And there's been an enormous amount of interest from the utilities in the UK.
That's awesome. Were there any surprises in it for you, either welcome surprises or unwelcome surprises?
No unwelcome surprises. I think the biggest surprise has actually been just the amazing thought processes that the entrants have gone through to get from this very early stage, quite high brief in terms of the problem statement for the challenge, to where they've ended up now with solutions that are feasible. They are technically proven, at least on a small scale, at a laboratory scale, and the potential for them is massive. But I think one of the things that's been most surprising was the feel of the cohort. So it's not about the technology. It is about how well that group of participants work together in a competitive environment, but they learn to overcome those, share enough information to allow themselves to still remain competitive, but created that real peer group that supported each other and really celebrated at the end when not all of them did get through to that final podium, but all succeeded through that process. So I think that was probably the most exciting or interesting or beneficial output from my perspective.
Fantastic. Thank you very much. That's a great introduction to Aqualunar. And now we're going to hear 3 of the teams presenting their tech.
I'm Sean Fletcher. I'm a first-year PhD student at the University of Glasgow. We have done some research in how to use ultrasound to attack pollutants that would be in water domestically. And it just seems like a very interesting step to kind of take that to the next level and look at kind of wider applications. That's something that this challenge offers. And also the fantastic non-financial support that gets offered as part of this challenge, to be able to consult with these experts who are really leading the field. We do a lot of work in electrochemistry, and one of the things we've studied is how that works in low gravity environments. And it's kind of fascinating to see the differences between things that happen here on Earth versus how they might happen in space with low temperatures, low gravity, extreme conditions. And it's an absolutely fascinating challenge trying to kind of develop adaptations for that technology to work up in space or on the moon or on Mars or further afield than that.
My name is Abigail Charlton. Our project is called TIDAR. To think about the fact that we could actually create a technology to make water on the moon is just amazing. The idea that we can be a part of the step towards some sort of lunar economy in itself is more than enough to just make it worth it. It's been really, really amazing to chat with some of the other folk and to learn things from the panel as well. They were super interesting. Definitely excited about the future. Come next March, whether we get that prize or not, we will definitely be looking to innovate in the space environment because there's just so much potential there, and just a small team like NASCENT can really branch out into something huge, I think.
My name's Philip Baldock. I am trained at the university level as a physicist and materials scientist, but really my passion is space. And that's really what's brought me to this Aqualunar challenge. Our concept, which we're calling Ganymede's Chalice, is basically to use a solar concentrator to take sunlight and focus it in to a single spot where we preferentially evaporate one by one each component of the lunar ice regolith mix. I'm really excited by what I think we might be able to achieve with native European technologies and with cooperation locally. I think it has a lot of potential really to make some interesting new ideas. I'm really glad to be part of it.
These three finalists are developing very diverse technologies. In lunar sonic system, melted ice is pre-filtered to remove particles, then processed in a sonoreactor where ultrasound breaks down the volatile compounds and flocculates the lunar dust. Final polishing is done via lunar regolith filtration. TIDAR employs UV light from LEDs to activate a titania catalyst and diamond electrodes, which are robust enough to withstand the abrasive lunar soil and the G-forces experienced during launch. It rapidly breaks down both inorganics and organics in the lunar soil to create drinking water and rocket fuel. Ganymede's Chalice is a solar concentrator, a curved mirror to focus the sun's rays on an air-locked crucible where lunar ice is placed by a small automated crane. The heat from the concentrated rays boils the ice components one by one, and the system stores each component separately, finally condensing potable water. If some of these sound more like fiction than fact, we have to remind ourselves that these are very young technologies, and of course they haven't been tested on the moon yet. But the Aqualunar innovators are building on a long legacy of curiosity and imagination. Science fiction as a genre emerged in the 19th and early 20th centuries, but its roots can be traced further back as far as 1818. It truly exploded in the 20th century with the exploration of things like dystopia, robotics, and, of course, space travel. And science fiction often foretells what humans are capable of. My colleague Brad Lusk is not only a water scientist, but also a science fiction enthusiast and expert. So who better to give us a crash course on fictional water technologies that became fact? Here's Brad.
Hey everyone, my name's Brad Lusk, and I'm here today to talk to you about water in space. IL Utilities is participating in something called the Aqualunar Challenge. And essentially what this program is doing is contemplating how we're going to wrap our heads around having sustainable access to water on Earth by leveraging some of the technologies that are being developed to conserve water in outer space. It's really important and kind of cool to think about all of the ways that water has captured our imagination within sci-fi and the scientific community. Obviously, there's a lot of water research we do on Earth, but water has played a big role in a lot of the science fiction that has piqued our imagination and made us think about what the next frontier might look like. In outer space, you have very limited access to resources. You have to imagine you're up in your space station or on your spaceship, and it's very important to utilize and recycle as much of those resources as you possibly can. If you're up in a spaceship and you don't have access to an entire planet, You really need to think about every drop of water or element that is contained in your pee, in your poop, in the food, in the air, the phosphorus, the nitrogen, the oxygen, the water. All of these different compounds are going to be very important because you're essentially in an enclosed, self-sustained pod. And so we need to think about how it is we can use some of these technologies that we're developing for space to be implemented on Earth as water and these resources become scarcer. In the movie Waterworld, the polar ice caps have melted, causing massive flooding, and it's really hard to find land, and thus it's really hard to find drinkable water. There's a very famous scene in this movie where Kevin Costner's character is out on his boat and uses a miniature desalination and filtration system to capture, filter, and drink his own pee. Despite this kind of viscerally disgusting image of someone drinking their own pee, it does help the audience to imagine the kind of innovative technologies that can be created to help us conserve and sustain life when access to fresh water is limited. This situation parallels a lot of the technology that we've developed in the real world. When we're thinking about regions of the world that are becoming more drought-stricken, or the groundwater is becoming inundated with seawater due to coastal erosion, we think about places using desalination technology or planned potable reuse for recycling water. Places like the west coast of the United States or Israel, where a lot of cutting-edge desalination technology and planned potable reuse is planned or occurring. We also see these kinds of technologies being implemented across industries like manufacturing, food and beverage, power plants, and data centers, where recycled water is filtered before it is introduced to cooling towers, greatly diminishing the demand for fresh water. On the International Space Station, solid and liquid wastes are separated. Separating solid and liquid waste is important because it allows the liquid waste to be recycled into drinkable water. If you imagine a future in which humans are traveling to or occupying other worlds, separating solids and liquids also simplifies the nutrient recovery process. Essential nutrients like nitrogen and phosphorus can be recovered from the liquid fraction while producing drinkable water for the astronauts, while the solid fraction can be converted into biosolids and used for sustainable agriculture, as we saw in The Martian. Although much of our plumbing infrastructure mixes solids and liquids as a consequence of being developed over 100 years ago, separating solids and liquids to recover valuable nutrients and biosolids here on Earth is becoming increasingly a more common practice. Another example we can think of is Luke Skywalker's character in Star Wars. Luke Skywalker is a farmer. I think a lot of people know that. But what's interesting is the kind of farmer that Luke Skywalker is. Luke Skywalker is a moisture farmer. He harvests water from the air on Tatooine using something called an atmospheric water generator that harnesses solar energy to condense water vapor into liquid water. Basically, the water that's in the air is now able to be captured, recovered, and consumed. Perhaps George Lucas made Luke a water farmer in the middle of the desert to provide foreshadowing for Luke as the savior of the Republic. He's the person that provides water, the substance essential for life, against all odds, in the middle of a drought, in the middle of a desert, and in the middle of an intergalactic battle for the cosmos. Obviously, technology for harvesting water from air at scale is very expensive compared to, say, groundwater or using recycled water from a wastewater treatment plant. However, when you're thinking about inhabiting extremely remote locations, extremely arid lands, places like Tatooine or a space station on Mars or the Moon or some other celestial body that has humidity in the air, you can see how very quickly the economics start to reverse. The cost of shipping a liter of water from Earth to Mars becomes astronomically expensive, whereas the cost of using something like solar power to condense water vapor from the air in a remote location becomes extremely cost-effective. As you all are listening to some of the technologies that we're talking about today from the Aqualunar program, I encourage you all to stay innovative, to stay creative, and to think about ways to transform your ideas into tangible realities. The theoretical situations we entertain ourselves with in sci-fi and space travel are exactly the situations that get us contemplating blue sky thoughts that might lead to the next breakthrough. perhaps to occupy new worlds, or perhaps to provide the next leap in water innovation here on Earth.
Brad, thank you. That was unbelievably cool. The Aqualunar competitors are, of course, all striving to make their technologies the one to make that next leap. And I'm happy to now show the winners. The second runner-up is Aqualunar Pure. The first runner-up is the Filtered Regolith Aqua Neutralization Kit, or FRANC, and the winner is the Sonochem system by Nika Scientific. Three very different technologies again. Aqualunar Pure is a supercritical oxidation reactor, which will first heat lunar ice to leave behind dust and rock particles, then increase the temperature and pressure further to create supercritical water, not a solid, a liquid, or a gas, but a fourth state, like a thick vapor, in which oxidation will simultaneously remove all contaminants. FRANC is a three-stage approach designed to deliver a continuous flow of drinking water. It would first heat the lunar soil in a sealed chamber to drive off volatile gases and leave a liquid mixture behind of water, methanol, and regolith fragments. The liquid is then filtered through a membrane, and the filtrate is distilled to separate the methanol from the water. Finally, the winning technology uses microwaves to defrost lunar ice, then ultrasound to break down the contaminants and provide potable water. Sonochem creates millions of tiny bubbles in the meltwater. The extreme temperatures and pressures created within the microbubbles generate free radicals, which effectively remove all contaminants. Let's hear these three winners.
My name is Edo Boek. I'm currently a professor in chemical engineering at Queen Mary University of London. We've developed the concept of water purification using a one-step concept, a process called supercritical water oxidation. We take water up to high temperatures and high pressures where water is a very thick vapor. All the contaminants will be destroyed by the supercritical water. The technology we develop for the moon, in fact, is suitable to treat the contaminants in terrestrial water. So we'll have direct impact on the water problems we encounter today on Earth. Other projects that I've applied for, they weren't nearly as exciting as this one. This would really spark the interest of both my students and myself, and I think this is an example how it should be done.
Team FRANC is a system that's designed to purify lunar water. We're going to use ultrafiltration and a distillation process. Between us, we feel we've got a good chance of coming up with a solution that will work. The reason we thought this challenge was really interesting is not only is there the financial backing to help us develop our product, but we get access to a huge range of support. I'm looking forward to having this opportunity to build hardware that could one day in the future be operating on the moon and providing drinking water for astronauts. But over the next couple of months, I'm really looking forward to seeing our concept become a bit more of a reality and starting to test and prototype elements of our design.
My name is Lola Nika. My concept is to use the power of ultrasound to create millions of tiny, small bubbles within liquid water. These expand and collapse, creating high temperature, high pressure microreactor environment that generates free radicals and decomposes contaminants. It's really difficult to build and commercialize space technology, but with Aqualunar Challenge, they provide a platform for finding and furthering that technology with a commercial customer in the terrestrial environment. The process is really well structured to come up with a concept that is valuable to the team, even though they don't go forward, and valuable to both the space industry and the water industry.
Huge congratulations again to all of the winners, but especially Nika Scientific. Since undertaking this challenge, Nika Scientific have raised over £230,000 in investment, and Sonochem has been accepted onto a payload that will fly in 2026. And finally, music on Mars. NASA's Curiosity is a car-sized rover which has been exploring Gale Crater and Mount Shar on Mars since 2012. As of 22nd of May 2025, Curiosity has been active on Mars for 4,533 sols, which is 12 years, 289 days. Curiosity's mission includes investigating the Martian climate and geology and looking for signs of past life as well as for the elements to support life in the future, including water. The soil testing equipment called SAM, Sample Analysis at Mars, resonates and it makes a buzzing sound. And the pitch of the sound changes depending on exactly what Curiosity is doing. It sounds like this. So some of the finest minds currently alive decided to use this incredibly sophisticated and important piece of equipment and work out how to make it move in just the right way to sing a tune. On Curiosity's Martian birthday, 5th of August, they took a birthday cake to Mission Control so that a room full of brilliant scientists and engineers could throw a birthday party for a non-autonomous robot 225 million kilometers away and listen to it sing the first ever song sung on Mars, which was Happy Birthday. What a lovely story about the ridiculousness of humans and the way we love things. We built a little robot and we called it Curiosity and flung it into the stars to go and explore places we can't get to because its name is in our very nature. And then just because we could, we taught it how to sing. With that, we come to the end of this month's broadcast. Once again, I thank our generous sponsors shown here. Next time, Piers will be back with a success story from the Samoa Water Authority, marine carbon capture, an interview with the Institute of Civil Engineers, and a great technology showcase from Somotics. I hope you'll join us. Until then, keep asking questions, keep sharing, and keep safe.